Hello everyone. Today we are going to perform eigenvalue buckling analysis of a circular and hexagonal column having same mass and length values. So please subscribe to this channel for more amazing content. First of all, we are going to add the circular and hexagonal column geometries to the structural analysis. We are going to use structural steel as the column material, having a yield strength of 250 megapascals. The hexagonal and circular columns have same length of 100 mm. The mass of both the columns is also same, equal to 245 grams, so that we can compare which is better in sustaining vertical loads. Next, we are going to add the eigenvalue buckling module into the solution of the static structural module. We are going to select the structural steel as the material for the geometry. In the mesh section, we are going to use sweep type mesh method. And as for the mesh size or element size, we will use size of 1 mm, and for the mesh element order we will use linear type so that we can have less number of nodes. We are going to add the fixed support and force value of 1 Newton in a negative z direction to the bottom and top face of the column. Next, we are going to add the results of total deformation and von Mises stress values. Then click Solve option to solve the structural analysis. Then in the buckling analysis, change the pre-stress environment to static structural option. In the analysis settings option, set the maximum no of modes to only 2. Then insert the total deformation results and change the mode to 1 and 2. Then click Solve option. In the results there are 2 modes, one is in the x-axis and other deformation in the y-axis. Next, we will go to eigenvalue buckling analysis and click Setup, Edit. We are going to follow the same steps as we did for the circular column. And we are going to find the same number of modes as we did for the circular column. Next we will add the Eigenvalue buckling solution option to the model option of the structural analysis. And also we'll do the same for the engineering data. Next click the solution option of the buckling analysis to set the scale factor to 1 and mode value to 1. You change the scale factor value to see the extra deformation values. Now again add the fixed support and force value of minus 10,000 newtons in a negative z direction on the same phases as before. And now we will find the final total deformation, von Mises stress and safety factor values of the circular column. Now repeat the same steps for the hexagonal column as well to find the final results, and then we will compare the column results side by side. Now you can see that the hexagonal column has large deformation value than circular one. The stress value of hex column is also higher, and it's high because the hex column has a sharp corner. The safety factor of the circular column is much more than hex column, so it is concluded that circular shape is much reliable than the hexagonal in vertical loads condition. Thanks for watching. Please subscribe to this channel for more amazing content.